Page 6 of the notes is describing distributions with numbers. So we have our measures of center that we're going to use. We have the mean, which has this symbol, which is x bar. So right here it's pronounced x bar. An arithmetic average, that's what the mean is. So if you guys used averages before, you've used means. To calculate the mean, you add all the values and divide by the number of observations. Here's a really complicated mathematical look at how to calculate. X bar, the mean, is equal to each observation all summed up divided by however many there are. Another way to say that is it's 1 over however many there are times the sum of the observations. This capital sigma here means summation, or summing up the observations. And this I just says you take the first one plus the second one plus the third one until they're all gone. So this is the sum of all the observations. That's on page 38. On page 39 of your text, they talk about the median. The median is the midpoint of the distribution. You arrange from smallest to largest. If there's an odd number, you pick the middle value. If there's an even number of observations, you average the two values in the middle. You can think of the median as if you took your pencil and you tried to balance it on your finger. There's the midpoint. Okay? So you take all the observations from smallest to largest. If there's an odd number, it's the one in the middle. If there's an even number of observations, it's the average of the two in the middle. So you add them together and divide by 2. Now comparing the mean and the median. Unlike the median is resistant. What that means is if you have outliers to one side or the other, so you have a super small number and then the rest are sort of close, what that's going to do is it's going to make the mean smaller than, it's going to pull it towards the smaller value. The median would take, when you have the median, you take the smallest one and the largest one and you drop them off and you continue until you get to the middle. So it doesn't matter if there's really small outliers or really large outliers for the median. But really small outliers and really large outliers will affect the mean. Your middle of your data set, if you use the mean, will be off if there's outliers. So whenever there's outliers, we'll use the median. Whenever it's somewhat symmetric, no outliers, we can use the mean. If the data is perfectly symmetrical, those two measures will be exactly the same. The mean and the median will be exactly the same. If our data is skewed, the mean is further out in the skewed tail than the median. So if you look at a picture, let's say we had skewed left, which if you remember looks something like that. So if this is the center, the median will be more towards the center, and the mean x bar is going to be pulled out towards this tail, because these outliers out here pull the mean out, but they don't pull the median out because the smallest one and the largest one just cancel each other out until we get to the middle. Okay, the next thing we're going to do is we're going to use our calculator, and there's a stat button on our calculator which we're going to use to enter these statistics for St. Louis into a list and these other statistics for San Francisco into a different list. So what you want to do is get your calculator out, make sure it's on, and we're going to enter these values into list 1 for St. Louis. So the temperatures for St. Louis during the 12 months. So if you hit the stat button, I'll make sure you can see everything on the screen here. The stat button is right here on the TI-84. Hit stat and then hit edit. Now it'll give you a list 1 and a list 2. I've already entered all these numbers into list 1. So right now, enter these into list 1 and these numbers into list 2. Okay, once you've done that, You have all the data for St. Louis, and you have all the data for San Francisco. Now, if we want to calculate their mean and their median, we could do it by hand by adding these up and dividing by 12 to find the mean, and then numbering them from smallest to greatest, canceling out the first and the last, the second and the second to last, and so on to find the median. But the calculator can take that list and do it all for us at once. So if you hit Stat button again, and then go over to Calculate, and we're going to do just list one. So do the one variable stat, hit Enter. Make sure that L1 is here. If it's not, you hit second, and then number 1 on the calculator has a blue L1 on it. You don't need a frequency list. Go down to Calculate and hit Enter. It gives me an X bar value of 55.3, which is the mean here. And if you scroll down, it gives me a median value of 57. So we don't have to reorder the list to find the median. We can just enter the data into one of our lists and calculate it. Now let's go back and do that for San Francisco. So go to Stat, over to Calculate, and do a one variable stat, but now I'm going to hit second 2 to put L2 in the list I want. Then go to Calculate, and the X bar value is 56.8. So the mean temperature is 56.8. If you scroll down, you'll see median, and the median is 56.5. So it has a median temperature of 56.5. So we can use our calculator to enter the list in